Okay, so this video is about rational functions and graphing them. Well, first off, what is a rational function? A rational function is just a polynomial divided by another polynomial. So, for instance, if I have f of x equals x squared minus 9 over x minus 3, this is a rational function. So the first thing we're going to talk about is the domain of a rational function, which is very important to know. So the best way to find the domain of a rational function is, well, you look at the denominator, right? Well, it's division. So the only number you can never divide by is 0. It's mathematically impossible. So if you set the domain equal to 0, then we know that, yeah, you add 3 to both sides and that x equals 3. So this is the only value where the function is undefined. So the domain is, all real numbers except x cannot equal 3. So again, the domain is all real numbers except x cannot equal 3. Or in interval notation, it would be negative infinity to 3 union 3 to infinity, where 3 is not included. So another example that we can go through is, well, say I have g of x equals x over x squared minus 9. Well, again, I set the denominator equal to 0, solve for x. I can add 9 to both sides. I could also solve by factoring. So I get x squared equals 9, take the square root of both sides, x equals plus or minus 3, since it's a second degree polynomial. So then that means the domain is all real numbers except x cannot equal negative 3 and positive 3. So in interval notation, I'm going to write d for domain with a colon. That's going to be negative infinity to negative 3 union negative 3 to 3, and another union with 3 to infinity, where none of these are included. That's why I have parentheses. If it was included, I'd have brackets. So that's the domain for that one. And then now we'll do one more example of, okay, say I have h of x equals x plus 3 over x squared plus 9. Okay, well, I set the denominator equal to 0. Solve for x. I get x squared equals negative 9. Take the square root of both sides. Well, since I'm taking the square root of a negative, I already know it's an imaginary number. So x is going to have to be equal to plus or minus 3i. It's an imaginary number. So that means that since our x values are imaginary numbers, that means the domain is all real numbers. So then the domain is just negative infinity to infinity. So now let's go into something else that's very important with asymptotes. Let me just clear rational functions. Let me just clear this. And that is finding vertical and horizontal asymptotes. So suppose I have f of x equals x over x squared minus 9. Well, what are vertical asymptotes? Well, believe it or not, A vertical asymptote is where a function is undefined, and what happens is a curve gets very, 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 very close to a dashed line, but never actually touches it. And horizontal asymptotes are the same thing, except it's with y values, where the function, where a curve gets very close to that particular y value, never crosses it, never touches it, but it gets like very, very, very extremely close. So for the vertical asymptotes, well, we actually already did that without even realizing it, because when you set the denominator equal to 0, that gives you your vertical asymptotes. So in this case, we had 9, x squared equals 9. Take the square root of both sides, x equals plus or minus 3. So vertical asymptotes, which I'll abbreviate as VA, at x equals -3, 3, or plus or minus 3. Now horizontal asymptotes, well, what I do is I take the highest degree in the numerator, the highest degree term in the numerator, and divide by the highest degree term in the denominator. So I would do x divided by x squared, which is simply what? Well, x divided by x squared is 1 over x. So that means that I have a horizontal asymptote, abbreviated as HA, or I know it's a terrible joke. Horizontal asymptote at y equals 0. Now, you're probably wondering, well, how the heck do you know that? You just memorize it? No, not really. If we take it back a step, suppose the way you can look at this is, well, if you pick a value for x besides 0, because that make it undefined, and you pick values, well, what happens as x gets bigger? So suppose I say x is 1. That would give me, well, 1, right? Because 1 over 1 is 1. And if x is 2, that gives me half. If x is 3, that gives me 1/3. And if you notice what's happening, as my x value is increasing, the value of the expression here when I plug in my x values is getting smaller. So as x gets bigger, y is getting smaller. So that means that it's going to wind up approaching 0. And similarly, if I had it as the other way around, x squared divided by x, well, that's just going to be x. And what happens as x gets bigger? If x is 1, I have 1. If x is 2, I get 2, 3, 4. It gets bigger and bigger. Well, what does that mean? Well, it's just going to get bigger and bigger and go on forever, so it winds up hitting infinity. Well, since infinity is not a finite value, that means there's no horizontal asymptote. So let's look at another example. This is a